My topic: development, pharmaceutical analysis, and in vitro evaluation of modified herbal fumigation formulations. I am Dr. Parikshit R Shirode, Professor, Department of Shalya Tantra, Parul Institute of Ayurveda, Parul University, India. So, coming to the introduction, Ayurveda is a science of life, and it has dual aim, Swasthya se Swasthya Rakshanam and Atura Sivika Prashanam, that is maintenance of the health of healthy individuals, and if anybody is ill, treat the illness. Acharya Sushruta, who is also coined as father of surgery, explained approximately 300 surgeries, 121 instruments, 101 blunt instruments, and 20 sharp instruments, dressing techniques, 60 measures for management of complicated wounds. He emphasized importance of asepsis by the term Raksha Karma, and Raksha Karma, that means preventive aseptic measures. Dupan is an integral part of Raksha Karma. Dupan means herbal fumigation with various medicines of herbal, mineral, and animal origin having antimicrobial properties. These medicines produce aromatic fumes on heating. These fumes are helpful to purify air, and such aroma makes environment pleasant. Since ages, herbal fumigation was indicated as preventive measure, that is fumigation of wards, operation theatres, neonatal and obstetric wards, labor rooms, etc. And also as a therapeutic measure for the management of wounds, ulcers, gynecological urogenital infections, otorrhea due to various reasons, chronic febrile illnesses, psychological conditions, etc. So the herbal fumigation is explained as a broad spectrum therapeutic as well as preventive modality in Ayurveda. In modern science, it has very limited implications in regards of environment and area fumigation only. So nosocomial infections, that is hospital-acquired infections, are really challenges in modern hospital setups. These are very common, and these include catheter-associated urinary infections, central line-associated bloodstream infections, surgical site infections, ventilator-associated pneumonia, and Clostridium difficile infections. Surgical site infections are very common and dangerous in all the hospital-acquired infections. A point prevalence study conducted in Germany in 2015 and 16 included more than 2 lakh patients across 947 hospitals, concluded that about 19.5% of patients in ICU had at least one hospital-acquired infection. As per the study conducted during March 2014 to August 2014 in Pune, India, prevalence of hospital-acquired infection was 3.76 in tertiary care unit, while in surgical intensive care units it was very high, that is up to 25%. So, according to National Healthcare Safety Network, the common causative organisms for surgical site infection includes Staphylococcus aureus, coagulase negative staphylococci, enterococci, E. coli, Pseudomonas aeruginosa, Enterobacter, Klebsiella pneumoniae. So, sterilization and disinfection is very critical in operation theatre and wards. Commonly used fumigating agent is formaldehyde. It is effective, but it is very irritant and carcinogenic, and hence not safe for the hospital workers. Though safer chemicals are arising, but they are very costly and not within the reach of hospital setups in the developing countries, though developed countries are using them very common. So development of multiple drug resistance, extended drug resistance, total and pan drug resistant microorganisms is really a big challenge while combating infectious diseases. And development of new potent antimicrobials is time consuming, costly, and almost no new antibiotic is introduced since last almost 2 decades. Pharma industry is very expectantly looking forward towards development of novel pharmaceutical formulations to combat resistant microorganisms. During COVID-19 pandemic, Ministry of Ayush advised fumigation with medicated herbs as preventive measures. Uh, there is really a need for safer, affordable, eco-friendly alternatives for formaldehyde fumigation. These are very common. The formaldehyde fumigation is very common in developing countries where most of the population lives. It is proven that many herbal medicines are having potent antibacterial properties. Effective disinfection for wards and protein complex is also achieved along with alternative uh, chemicals. Integration of traditional knowledge with modern analysis is very important to validate these new formulations. So, develop the objectives of this study are development of modified herbal fumigation formulations, conduct pharmaceutical analysis, perform in vitro antimicrobial evaluation. So, the methodology, this is a gross methodology, and for every formulation, I will explain the methodology there. Selection of classical herbs, modification of formulations, pharmaceutical standardization, in vitro antimicrobial evaluation, and comparative assessment with formalin. Selection of classical herbs. Many polyherbomineral fumigation formulations are advocated in Ayurveda texts. Amongst them, Icorus calamus, Brassica campestris, Commiphora mucul, Azadirachta indica are the common contents of most of the formulations. The author has tested the efficacy of herbal fumigation formulation containing these four herbs as a therapeutic as well as preventive measure. Selection of classical herbs. The classical herbs, as explained last slide, the part were used like rhizome of Icorus calamus, seeds of Brassica campestris, leaves of Azadirachta indica, and resin from Commiphora mucul. The various formulations tested were classical raw powder formulation. Then we modified the decoction formulation prepared from raw powders. Further, further hydromethanoic extract was prepared from raw powders and pellet at the end. Device in classics specific Dhupan yantra for the purpose of fumigation is described, and this was modified. I will explain it later. So, classical raw for the preparation of classical raw powder formulation, the all the herbs were finely powdered and properly mixed in equal quantity. For decoction preparation, It was prepared as per a classical reference from Sharandhar Samhita. All the properly mixed raw powders were kept in a vessel. 16 times water was added to the vessel. The vessel was provided moderated till the water contents were reduced to one-fourth of the initial amount. And uh, for hydroalcoholic extract, it was actually hydromethanolic extract with 30 as to 70% proportion of water and ethanol. All the raw powders were taken in the ratio of 1 as to 1 as to 1 as to half, as Google found very viscous uh, consistency in liquid form. It was taken half proportion. This is the methodology adopted for hydroalcoholic extraction. Uh, pellet formation, all the raw powders were taken in the ratio of 1 as to 1 as to 1 as to 1. The coarse powder was grounded with water to form a fine paste. 5 grams of the paste was taken and put on a butter paper. Another butter paper was covered over. The paste between the butter papers was pressed evenly to form a pellet. So the pellets formed were dried in sunlight, and these were kept in butter paper and aluminum foil and preserved in airtight containers. This is the modified herbal fumigation apparatus. Uh, for in the context of Ranadupan, Acharya Sushrut has explained a device which contains two earthen saucers. The other saucers are placed invertedly one over another so that a chamber is formed. The lower chamber contains the herbs for fumigation, and upper chamber has a core in its center. That center carries 8 inches long tube. Acharya Sushrut has uh, also precise the inner bore that carries horse gram, and the outer bore has a maximum circumference of chickpea. So according to that, as during my PG days, I ordered such other than apparatus, but it was not handy, good looking, very heavy to carry here and there. It broke up. So I found I prepared alternative device, which is till now we are using very successfully, and many Ayurveda practitioners adopting the same methodology for fumigation. Initially, as a heating source, it carried electric heater with temperature control. Now we use uh, induction cookers. For that, lower chamber was replaced with thick steel plate, and upper chamber was replaced with metallic funnel. The funnel the nozzle of the funnel was of exactly dimensions as mentioned by Acharya Sushruta. So, for pharmaceutical analysis, physicochemical profiling, GCMS and HPTLC markers identification, active phytoconstituents linked to antimicrobial properties, and ultimately standardization for reproducibility. The organoleptic profiling of these various formulations revealed that the powder was grayish black in color and had fragrant odor. The delusion was brown, clear liquid, uh, and having characteristic odor. Extract was golden brown and with aromatic odor, and pellet were grayish black with pleasant odor. Uh, the physicochemical profiling revealed that powder uh, had a pH of 6.02, decoction 5.05, extract 6, and pellet 5.80. it is very notable that all these formulations had alcoholic, sorry, not alcoholic, acidic pH. This is very important for any antimicrobial formulation. Specific gravity was 1.113, 1.007, and for extract it was 8894. For pellet it was not available. Viscosity of decoction and extract was only available. It is 0.79 and 0.8188. The solid content in terms of percentage weight by weight. For decoction, it is 1.71 and for extract it is 1.17. Total ash value in terms of percentage weight by weight for powder 0.79, for extract 0.55, and for pellet 1.59. For decoction, it was not available. Refractive index 1.2745 for powder. For extract 1.3275 and for pellet 1.928. Boiling point of extract was 74 and for pellet it was 3.738. For other formulations, powder and decoction. So, for HPTLC and GCMS analysis, the samples should be in liquid form. And already for extract, we chosen 30:70 hydrometallurgic mixture, and for decoction it was water. Remaining two formulations, powder and pellet, were in solid state, so hydroalcoholic extraction of these were prepared. And to maintain the continuity for powder formation, it was chosen 1:1 hydroethanolic solvent, as for and for pellet 1:1 hydromethanolic solvent. So this polarity balance ensured the better extraction of alternatively powder to non-powder particles. So these are the findings of HPTLC analysis. For fumigation powder and fumigation decoction, all the wavelengths, that is 254, 366 and 540, were observed, but for extract and pellet formation, the higher wavelengths were not observed. It was observed that for Dupont, that is a fumigation powder, at 254 nanometers, 54 spots were ranging from 0.028 to 0.078 were observed. This indicates that most probably the flavonoids and sterols are there. At 366 nanometers, 7 spots ranging from 0.39 to 0.88 were observed. Coumarins and terpenoids are most probably the phytoconstituent families. At 5.4 nanometer, 11 spots were observed. This gives wide chemical spectrum of 0.13 to 0.088. So this suggests that broad phytochemical retention of and strong fluorescence diversity with Dupont powder. Note that this is a hydroethanolic extract 1:1. For Dupont extract, that is hydromethanolic extract 30:70. At 254 nanometers, 4 spots were ranging from 0.024 to 939, indicating polar and non-polar extremes. And at 366 nanometers, 9 spots.
Sir, excuse me,
Ranging,
request
yes.
you to finish fast, please. Please mind the time.
Okay, so I come to conclusion of this HPTLC analysis. So we found that from 0.02 to 1, 0.08 range, RF value range. We found various uh, sorts. This indicates that phenolic acids, glycosides at lower range indicate antioxidant and antimicrobial activity. The flavonoids and tannins at a slightly higher range of 0.2 to 0.4 indicate wound healing, anti-inflammatory, and antibacterial force. Coumarins, alkaloids, these indicate analgesic, vasodilatory, and antiseptic properties. Sterols and steroids, these are lesser polar families. Anti-inflammatory and membrane relief actions are exhibited. And at the higher range, volatile oils, resins, non-polar terpenes were observed. These are the central to fumigation efficacy due to strong antimicrobial fumigant actions. So, GCMS profiling only done for extract and powder formulation, and decoction and pellet for these formulations it was not done. We found almost 31 for phytoconstituents, 10 for extract, and almost 25 for uh, powder formulation, that is hydroethanolic extract. So coming towards the discussion part of efficiency analysis and phytoconstituents found. So multiple phytoconstituents detected mainly in hydroethanolic extract classes like phenylpropanoids, terpenoids, sterols, fatty acid derivatives, and the, the terpenoids and sterols were lidol, dodecaptan, Coren, Lenesterol, cyclonas acetate, cycloterost. The functions are anti-inflammatory, membrane stabilizing, antimicrobial, and the importance is in these phytoconstituents enhance wound healing, modulate immune response. The phenylpropanoids like beta, alpha, and gamma aceron, isoylamicin, uh, methyl eugenol, benzene propionic acid, benzene methanol, having antimicrobial, antifungal, antioxidant activities, and phenolic acids and conjugates like dimethoxycinnamic acid, tyrosine, uh, having role of free radical scavenging anti-inflammatory, that is very strongly supporting wound healing, tissue regeneration activity. So GCMS confirms rich phytochemical diversity, identified compounds, antimicrobial, antioxidant, wound healing properties. This validates Ayurvedic Prandupan, that is herbal fumigation practice with modern evidence, emphasizes need for standardization of formulations. So extract specificity. So various extracts were used during this analysis, and according to that, it is found that hydroethanic extract enriched with sterols and terpenoids, solvent polarity extracts less water, less soluble compounds, and powders and decoction retain broader chemical spectrum. Note that these are the crude formulations. Implication: extract is potent but selective, having selective action, while decoction having synergistic and broad, somewhat discrete action. So now coming to the antimicrobial study, cultures where bacterial cultures of Staphylococcus aureus, Staphylococcus pyogenes, Staphylococcus epidermidis, E. coli, Pseudomonas aeruginosa, fungal culture of Candida albicans were procured from a repository of microbiology lab of PIMSR. Cultures of anaerobic bacteria Clostridium perfringens were obtained from repository of MTCC Jalandhar, India. So antimicrobial activity for pellet, it was only tested against Staphylococcus aureus and E. coli. And for that, the testing procedure adopted was pellet placed in incense burner. It was heated with release of fumes. Media plate exposed to in inverted form for 30 minutes to these fumes. Then the media plate was incubated for 24 hours at 37 degrees centigrade and growth observed versus control. The findings were pellet fumigation significantly reduced bacterial colonies. It was very potent against Staphylococcus aureus with approximately 70% reduction, and controlled heating preserves active volatile phytoconstituents, avoids degradation, loss of compounds seen in burning, demonstrates superior antibacterial potential of pellet fumigation. For extract, this was 30:70 hydromethanol extract. We carried comparative in vitro study with agar-well diffusion methods to understand serum inhibition against Staphylococcus aureus, E. coli, Pseudomonas aeruginosa, and Candida albicans. Samples were 30:70 hydromethanolic extract, blank. Then sample B with 1:1 hydromethanolic extract and blank. It was found that the 30:70 hydromethanolic solvent is more effective than all the other solvents. So what I want to highlight here, that various formulations are described by Ayurveda text in regards of fumigation. Fumigation is indicated for the management of various calamities, as well as for the purification of environment. This is broad spectrum drug delivery system. This is novel for the modern sciences in regards of most of the conditions where Ayurveda indicates. So, but this is very commonly used in society. But the validation of that formulation is was pending. Since last 20 years, I am working in this field, and during this period, as I explained, I modified the Brandupon, that is a herbal fumigation apparatus. Few problems with powder formulation I detected, so I
Please
modified the
adhere to
formulations
the
also,
timing,
and I
sir. Conclude your
yes, yes,
topic,
yes.
please.
I'm concluding. I'm concluding, madam. I'm concluding,
No
madam.
time
I'm
for
concluding.
discussion then, sir. No time for interaction.
Yes, yes, yes. So finally, we found that the herbal fumigation formulations have effective antimicrobial activity. These are safer and non-carcinogenic, cost-effective for resource-limited settings, support traditional Ayurveda with modern validation. Meanwhile, we also conducted a study against formaldehyde fumigation, and we found that it's much safer than formaldehyde. Still, it is lagging behind. It is not as potent as formaldehyde in OT fumigation, but ward fumigations we can use it very safely. So it is a further future scope, large scale clinical validation, standard device development. So device should be modified, eco-friendly OT and ward fumigation method. This is, and it should be popularized. So, very short conclusion: modified herbal fumigation is effective, safe, and affordable. Bridges Ayurveda and modern pharmaceutics. Potential contribution to infection control in healthcare. So, I give special thanks to Dr. Hemant Tushikare, the Dean Faculty of Ayurveda, Parul University, Vadodara. sincere gratitude towards Dr. Devanshu Patel, President Parul University, Dr. Parul Patel, Dr. Deepika Patel, Dr. Komal Patel, all Vice Presidents of Parul University. Thanks for